Now today we will see the georeferencing part, that is georeferencing a Toposheet using SAGA GIS. And as I earlier indicated in previous sessions, that the data and the PDF, that is the content and the data we are going to use from the dstiget.in website. You can just go to this link and download this PDF and data. I've already downloaded it, so we'll be directly using it. This will be our fourth IGT RS004 series or fourth PDF for georeferencing a Toposheet. So you need to follow this. And the fourth data means 004 data. Let me unzip it for you, because once you download it, it will be in the zip file. So you need to unzip it. And once this data is there, we are going to use this South Pune Toposheet.tif. Right? This data we are going to use. And let me open this SAGA GIS for you. This is SAGA GIS 64-bit 3 version. Okay, you don't have to install it. You can just download it and you're good to go. So the objective today is to reference a Toposheet by using Graticule or Graticule ticks intersection in a known coordinate system and data by using this SAGA. And the prerequisite is that you should have this SAGA on your system, also familiarity with this SAGA, and previous exercise needs to be completed. Let us make a empty project. The georeferencing is, first let me make yourself comfortable with this georeferencing stuff. Georeferencing is a process of establishing a mathematical relationship between the image coordinate system to the real world spatial coordinate system. Right? In this exercise, we'll use a topographical map, which I just showed you of South Pune. This is prepared by Institute of Environment Education and Research, that is IEER. This is Bharati Vidyapeeth University, BVU, Pune. And this is the map which is in UTM, Universal Transfer Mercator projection, which is based on WGS84 data. So let me open it for you in Windows Photo Viewer. So this is the map which we are talking about. We'll use it. So let us go to our SAGA. Need to open the Toposheet. We must first import it into our SAGA GIS. For that, we need to use this import image, where you are going to find out this open or import image via some module. So import image. There are various options, and let me search it for you, but I don't want to search. I have a better option. What is the option? Go to geoprocessing, find and run tool, say just import image. Import image. Search it for this import image, and import image is there. Press OK. Now this dialog has come. From where it has come, I don't know. Where it is given in this SAGA, I don't know. I just searched it and just found out. So now import image module is there. And this is the dialog box. We need to click on the image file. This is the image file. Let me select this image file, which is this. So let me copy this path, paste it here, press enter. Now this is the TIFF image. And this is Toposheet.jpg, or you can rename it. It is up to you. And just select the Toposheet and click on open. Just press open. And enforce true color, you just press OK. It will be with you in this tree structure. Right? This is open now, and you can also go to the options, and we can change to the enforce true color, which we already did, because it was by default it was the enforce true color, and this will keep the color balance of the image. Now let me double click it. So this is the image. This is the image which we are interested in, but this is just a TIFF image, means just like the photo which you take from your mobile camera or from your any camera, TIFF, JPEG, a PNG. This is just like that image with no special, conformation, CONFORM, with the actual terrain, means with actual. We need to put that mathematical model, and that is what we are going to do, georeferencing. So you can view this Toposheet in the view just by double clicking it. We did it already. And then you can go to this description part, and you find it in the object properties. These are, the projection. This projection says undefined coordinate system. So which projection is there? No projection system, because this is just a simple image. So this indicates the Toposheet is not georeferenced and also not associated with any projection system. This is what we are going to do. We will associate it with some coordinate system. So to georeference a raster image, we use these ground control points, GCPs, to assign a real world coordinate system, which means the process of georeferencing in this, we will establish a relationship between pixel coordinate system of the raster file to the geographical or projected coordinate system of the Earth. So we are matching this TIFF or plain JPEG image with the Earth. So when you place it on any on the globe in any software or in any application which require that image to be geographically equipped, then it will be placed directly on that area which that image belongs to. So we need to use distinct sharp features which can be easily identifiable. So in satellite images, we use road junctions and building corners, but in the case of our Toposheet, we'll use the graphical intersection of the latitude and longitude because we know the geographical coordinates of them because this is the Toposheet. So to start adding GCPs, start the create reference point modules. So where to find? Let me find it out. Create reference point. If it is there, georeferencing you can find. Go to various options. You can choose. What you have to find is create reference points, but I'm not able to find it out, and so many of you will be. So I don't want to waste my time on this. Let me just find it out. Go to search and just place create reference. If it is there with this name, it will come. Otherwise, we'll find again. So this is create reference point. From where it has come, I don't know. I just found it out. Okay. Now this is the create reference point, which is interactive. This module is marked as interactive. Why? Because it requires the user to input data while the module is running. So when the module opens, we click OK. So this will start the module. A new point shape file layer will be seen in the data list, right? So these are the reference points in SAGA GIS. If you what you can do, you can just press OK if you want. Once I press OK here, you see that this shape has come, shape point, reference point. But what has happened on the background is the module is interactive because when you pressed OK, the module will start automatically on the background. So a new shape file layer will be seen in this data list, as you can see here. So this SAGA GIS, the reference point module, this is basically creating a shape file with two attributes, X and Y. See, if you see, these are 2 points, which is X and Y. So let me show you the expression description. These are vertex points. See, only X and Y, which are used to store the latitude and longitude of a point as defined by the user. However, the coordinates of this shapefile itself are linked to the pixel coordinates of the original image. It has the attached origin tag. It has already origin tag. See, this is the origin tag. Now use this zoom tool. Go to the zoom tool. This one. Let me first find out some space so that we can work upon it. Zoom it. Zoom to extend. Zoom to extend. Now go to this zoom, right? And tool to view the area next to the top left corner of the top sheet and zoom it further to the intersection of the coordinate. Then this is where you are going to mark the first GCP. This is the point where I am talking about, right? This is the point. So note down this coordinate of intersection. This is 73 degree, 49 east, 18 degree, and here 18 degree, 28 minutes. So click on this arrow now. Arrow action button. The cursor will change to a positive sign. See, I clicked there, cursor has changed to positive sign, and then click on the center of the intersection, this intersection. So this will open a create reference point window, which will require you to input the X and Y coordinate of the GCP, right? So let me just click here, or if you want, you can zoom it further. This point, right? This is the point which we are talking about. Okay. Now this create reference point has come up. Create reference point. Click on this X position entry. Click X position entry, and you will see that at the lower half of the window, a comment will appear that X position floating point. This has come. Default value is also given. So this means that the coordinate will have to be entered in decimal degree format. Our coordinate are in DMS, which we just saw, degree minute second. And to convert to DMS to DD, means degree minute second to decimal degree, you just simply divide the minute value by 60 and add it to the degrees value, and then enter longitude in X position and latitude in Y position and click on OK. What I am trying to speak is, try to explain you is, see, we have points what were the point if you remember? 73 degree and 49 minutes. 73 degrees, okay. You divide 49 minutes by 60. Means, calculator, let me open a calculator for you. 73 is okay. And what I am speaking is 49 divided by 60. This is minute. And you just add it with the degree. Degree was 73 degree. So plus 73. Right? What is this? 73.8166 and 7. So copy it. Just copy it. Control C, copy. And paste it here. Or you can manually input also 73.81 and other stuff. Again, you have a Y position. Y position, it was 18 degree 28 minutes. Again, 18 degree will be like that only. You have to add it with 28 minutes. But how to make 28 minutes as decimal degree? Let me again do it for you. 28 divided by 60. What is this? 0.4666 something. Add it with the previous one, 18 degree. Add it with 18. This will be 18.466. Just copy it and then paste it here. Or manually enter it. Okay. Press tab. You have to press a tab to make it actually understandable to the system. Now these are in decimal degree. Simply we mark 3 more GCPs on the other corners and we use scroll button in the mouse for navigation. And once you are done with adding GCPs, end the module by unchecking it from the menu bar, that is module create reference point. Click yes on the pop-up window. So this is okay, right? This is okay. First point is being added. Right? Let me go to this other point. And this other point is, so this one. Zoom it for you. So what is this? 73 degree 52 minutes, 18 degree 28 minutes. Again, 18 degree 28 minutes, 73 degree 52 minutes. Let me open a notepad for you and I'll just type this so that you understand that what we will be changing and what will be the GCPs. So this will be 73 degree and 52 minutes. 52. And the other point is 18 degree and 28 minutes. 28 minutes. So this will be 73. We have already done it, but we'll do it again. What you are going to do is divide 52 by 60. 52 divided by 60. And add it with 73. Plus 73. So this is the first point. Copy it. Paste it here. Same for the 1828. So 28 and divided by 60. Then add it with 18. This is 18.46. Copy it. Paste it here. This is the second point. So what we are going to do is we are going to zoom it for you. See this point. Click on this action and just click it. So this has come again. Different position has come. X position, Y position, and you just have to give this value, copy and paste it, and then this value, copy and paste it. Press tab, and just press OK. Second point is also taken. Right? Go to the third point. This is the point. This is our point. So this is 73 degree 52 minutes. Let me open this notepad for you. This is notepad. Okay. So this is 73:52. 73:52 we have already done, right? So we'll directly take this, but let me write it again so that you will realize that this is another point. Third point actually. And then we have 18 degree 25 minutes. See, we have 18 degree 25 minutes. So 18 degree 25 minutes, and we'll change it to decimal degree. How? Divide 25. This 25 divided by 60, and then plus 18. Okay, copy it and paste it here. Right. So this point is also with us. Then go to that point. go to that point. Okay, this is the point, and take this and click it. Again, you have 2 points. So what you are going to do is open the notepad, take first point as this, and the second point is this. Press tab. Now you have two values. Now press OK. This is also taken. So third point is also taken. Let us go to the final point, fourth point. And this 1825 is already there. See, 1825 we already converted. So we'll take this directly as the second point, means the Y position, but X position we don't know. This is 7349. So this is 7349. So how to change it? 7349. Go to this, and this will be 49 divided by 60 plus 73. Okay, I think there is some problem. Don't worry. 49 divided by 60 and add it with 73. Copy it, paste it. Take these 2 points. How? Go to zoom, press this action and click here. Now you have this point 73.866, 18.4. If you see that it has already taken it, means by virtue of these positions it has taken, but we'll input the specific values which we have found out. This one and this one. Press tab, press OK. Done. So we have taken some points, 4 points of the corner. Okay, all points are with us now. 4 points, 1, 2, 3 and 4. These are the 4 points we have just taken. Okay, now what to do? The next step would be to close this. Okay, so we have marked 3 more GCPs, and we use the scroll button for navigation. And how to end the module by what? Unchecking it from the menu bar. That is, if you have this menu bar, you need to find out this create reference points, uncheck it, and it is saying shall execution be stopped. Click yes. Right, that module is finished now. So after adding GCPs to the image, you can have a look of added GCPs and the pixel coordinate associated with it, as we just saw here. And what you can do is, what you can do, these are the settings, right? And you can go to this data tab, and then this, because we have taken 4 points, so we'll go to this reference point. These are reference point, and go to attributes and show. So these are the 4 points which you have added, right? These are the points. Going to the attributes and clicking on the show. Now a new window has pop up. It shows the GCP coordinates we entered, and we can just close the table by clicking on red cross. We can close this also just by, because this is a whole new window has come. See, this is a whole window. And if you are not able to find out how to close it, just go to attribute and unclick it, unshow. So we have assigned a coordinate reference system to this image, and the coordinate system information will be published at the time of map print. In our map, it is printed just above the scale bar, just above this scale bar. Okay, use this zoom tool to zoom into the lower left part of the Toposheet just above this scale bar. This is the scale bar. The datum used for Toposheet is given as WGS84. If I can show you, zoom to layer, and let me zoom it for you this point. Because in every map it is given what is the datum, what is the projection. So this projection is UTM, datum is WGS84. Okay, and the projection is a UTM. So we'll use this information to assign projection to the Toposheet. Since we have entered the spherical coordinate, that is the latitude and longitude values, which correspond to this datum. So we'll georeference this map in Geographic Coordinate System GCS of WGS84 with these projection UTM and datum WGS84. So now open this coordinate reference system module via this module projection. So you can just go to and find. Well, I know SAGA GIS very well, but there is a problem that I'm not able to find out my require module. So what to do? Just press find and see coordinate reference system. It is okay. So coordinate reference system has come. This is set coordinate system or the set coordinate reference system. Okay. Now this module has started. This will open a window with the options for changing, assigning the projection to data set, and select the space next to your user defined. Here, user defined, and it is marked as 30 parameters. And click on this button. If you press it, a new box has appeared, which is user defined box, which is marked as which we just marked as 30 parameters. So user defined dialog will appear. There are several parameters for our projection, so we need to change the projection type. What is the projection type? This projection type will change it to what? That long geodetic. That long geodetic, right? This is already there, and we'll change the predefined datum to WGS84. It is already there, right? WGS84. Predefined datum to WGS84, and we'll press OK. Now this has come. See, the upper line has also changed. Proj for parameters, because on the background it is using this Proj for library. Then we can go to the data objects section in this set coordinate system. Data, various options are there. Okay, so this we have done. This data objects is here and grids. So no objects are there. What you have to do is just click on this entry, no objects or grids, and then click on this 3 dots. A new window has come up, and this will open a new window from where we choose a layer to be projected. Now select this layer, which is our South Pune Toposheet, and transfer it here on the right side, and just press OK. This has come up, right? And then select this Toposheet under this data list. This data list, and look at the entry next to projection. You will see that it is WGS84. First, you have to press OK here, right? This has been done. Now, what I am suggesting is select this Toposheet under your data list, and select this. Go to the description tab in the object properties, and look for the entry next to a projection. This is a projection. You will see that the given is GCS WGS84, and this indicates that the Toposheet is assigned to GCS projection or WGS84. And now we are ready to perform the georeferencing. Now you have to go to the georeferencing module. So go to modules, projection, georeferencing grids, and if you are not able to find it out, you can find it through find, and you need to fill some fields. How? Let me show you. So we have to go to projections, and then you can go to georeferencing. It is there. Georeferencing is there. Then you can go to georeferencing grids. So define georeferencing for grids. Rectify grid, move grid. You can directly go to this georeferencing. Define georeference for grids under georeferencing. If you are not able to find it out, what you are going to do? You just find it out. Means just search it. So under projection, georeferencing and georeferencing grid. There are various options here in the data objects. The grids, there are shapes and grids and etc. It has been asked. The reference point are also there. Various reference points are there. So this is one window, but this is not going to solve our purpose. So we'll again go back and find other option, projection, georeferencing, and we'll this rectify grid. Now there are options to choose. So this is a reference point. First you will choose here, then going to grid, and you will choose this one, and finally the grid. This is also not set. You can choose automatic or resampling as nearest neighbor or baseline. It's up to you. Resampling method is totally up to you. So press OK. Grid is invalid input, so we'll check what was invalid, because grid needs to be what we need to set. This is the grid. Okay. Another dialog has appeared, which is user defined grid, because we already chosen this, and now this is asking for user defined with the extents and number of rows and column. And if you just press OK, let it be like this. Press OK. Now see this progress bar. So this is a newly created layer which has just come up. If you can see, a newly created Toposheet has come, and this is now showing you the cell size, the extent, and which is having a new bead system. And open this new Toposheet in a new map window by just double clicking it. Okay, we have just georeferenced it, and as I move my cursor, if you can see, these are the lat long which are coming. See, the lat long which are coming. If you can change the color according to you, type RGB and apply. You have known that already. Now you can check the georeferencing by placing the mouse cursor over any corner tick of the map which you have already taken. So compare the value left to the status bar located at the right bottom of Saga interface. That is, I just want to go here and see these points which are coming here in the status bar. These are the points which we have chosen. And don't forget to save the georeferenced image. And for that, you can just right click on the georeference topo sheet under data type and select it as save as. You can just save as. And this is navigate to some desired folder. Save this grid and name it as some GOWGS84 Pune top shoot and save as type as SGID. So it will be saved as SGID. And then you can load again this SGID to Saga just by loading direct utility. You don't have to import it again because Saga this .sgid it reads directly. So if I can show you, just let me name it as today because I'll delete it after. Just to show you that how to save it and how to load it. Just open the file and open. So this has come again. This total has come. New same similar one. You can change the color. It totally depends on you what color do you choose. And you can also now close the project. You know how to close the project. File, exit. It will ask for saving. You can save if you want to save any unsaved save layers. Check the corresponding checkboxes of layers. These boxes which you want. You want to save this. You want to save this. Okay, whichever you want to save this and press OK, and this will be saved. So I hope you got the idea. It was not that typical as it sounds to be. So this is georeferencing in Saga for you. Thank you so much.